Hey everyone, want your UE5 project to read with a hand-drawn outline? You're in the right place. Today, we're breaking down outlines in UE5. We'll compare post-process and mesh-based methods, then build a clean mesh extrusion setup step by step. You'll see how smooth normals stop hard surface cracking and how Vertex Color Alpha controls thickness for a more hand-drawn look. Let's go. In most game projects, outlines are done in two main ways. The first is a post-process screen space outline. You detect edges from gradients in normals, depth, or pixel color. Think a Sobel pass, then threshold, and draw the contour. It's commonly used to highlight interactable objects. The upside is it's fast and doesn't require changing meshes or materials. The trade-off is it depends on resolution and TAA, so lines can thin out at distance and jitter during motion. The second approach is a mesh-based outline using normal extrusion. It's common in Toon-shaded games, and because it's geometry-driven, the line thickness stays consistent. You can also fine-tune outline color and thickness per character, or even per part. That's our focus today. Let me first walk you through the basics of a mesh-based outline. Here's a sphere intuitively. The outline is a ring around it. So the first idea is to duplicate the sphere in place, scale the copy up, and tint it black. But that black sphere will block the original white sphere. How do we bring the white sphere back? This is where backface culling comes in. Here is the eye, the camera, and in front of it is the sphere. In Unreal Engine, triangles whose normals point away from the eye are culled. By the same logic, if we render only the back faces of the scaled sphere, the front portion of that shell has normals pointing away from the eye and gets culled. So we only see the inside surface of the shell along the silhouette, giving us the outline effect we want. Let's open the material for the black sphere. To render the back faces, enable two-sided. Since we need to remove the front faces, set the blend mode to translucent. Use the two-sided sign node. It returns one on front faces and one on back faces. We want to keep only the back, so feed two-sided sign into a lerp, set the front branch to 0 and the back branch to 1, then plug the result into opacity. This cuts away the front of the sphere and leaves only the back, so you see the inner rim as the outline. Duplicating every mesh is tedious, and on complex shapes, it quickly falls apart. The good news is that from UE 5.1 onward, you can use an overlay material. It adds a second material pass on the same mesh. So, delete the black duplicate sphere, assign that black outline material to the mesh's overlay material slot, and hit play. You won't see a change yet, because the overlay sits exactly on top of the base material. We want the overlay to be slightly larger. So, in the overlay material, push the vertices out along the normals via world position offset. That makes the overlay shell sit just outside the original surface. Back in the material graph, grab Vertex Normal WS, multiply it by a scalar parameter to control the outline thickness, and plug the result into world position offset. His method looks great on smooth models, but on hard surface shapes like a cube, you'll see the outline break at the corners. Here's why, and I'll show it in Blender. By default, a cube uses flat normals. At a single corner, there are 3 face corner normals pointing in different directions. That gives you nice, crisp lighting transitions, but it's bad for outlines because the extrusion follows those diverging directions, so the shell opens up. What we want are smooth normals. Click Shade Smooth, and you'll see the normals average and align more consistently around the corner. That's exactly what we need for a continuous outline. Import the smoothed cube into Unreal and repeat the same overlay material setup. You'll see the broken outline is now fixed. We can't just change the mesh's normals, that would alter its shading. Instead, we'll store a copy of the smoothed normals in a side channel, like Vertex Color. In a production pipeline, this step is usually scripted in a DCC like Blender or Houdini. That's not ideal for indies, so I built an Unreal plugin that does it in-engine, no import, export, and it's easy to use on skinned meshes as well. You can get this tool on my fab. Next, I'll show you how to use it. In the Plugins window, find Local Outline Fix and enable it. Restart Unreal, then go to Local Outline Fix Content. Inside Smooth Outline Tool, you'll find an editor utility. Right-click it and choose Run Editor Utility widget to open the tool panel. Add the cube mesh to the tool and click Apply Smooth Color. The outline won't change yet, but you can see the mesh's vertex colors have been updated. Open the material graph. This time, don't use Vertex Normal because we wrote the normal data into Vertex Color. Use the Vertex Color node. Those values are 0 to 1, while normals are 1 to 1, so multiply by 2 and subtract 1 to remap the range, then normalize to ensure a unit vector. Note that we stored tangent space normals, so convert them here. In most cases, you should use tangent space normals, so the model behaves correctly when it moves. Back in the scene, the outline is fixed, and the cube's lighting is unchanged. Next, I'll demo this on a skeletal mesh. By default, the hair outline isn't complete. Switch to the skeletal mesh and load it into the tool. Great. The hair outline is now fixed. Turn on Vertex Color View. The bangs area shows updated colors, while the body remains a mostly uniform normal color because those surfaces are already smooth. Now that the outline is clean, let's fine-tune thickness with Vertex Color Alpha. In the material, multiply your outline width by the Vertex Colors Alpha. Open Mesh Paint mode, paint only the alpha channel, and set the value to 0.4. I want the outline thinner near the knees, so I'll paint that area. Lower alpha makes the line thinner, higher alpha makes it thicker. That's all for today's tutorial. If there's anything else you'd like to learn, let me know in the comments. You can find more Toon shading tools on my Fab page. If this was helpful, consider subscribing, and I'll see you in the next one.